Okay, today we're going to look at lesson 9.3. This is solving the quadratic by completing the square. We looked at completing the square the other day by just getting vertex form. This time we're going to take it one step further and actually solve that whole equation instead of just converting. So a little review first. Use the zero product property to solve the quadratic equations below. So when we do zero product property, all this means is check for a GCF, then do your snowflake. So we're going to check for a GCF. So we put each one of those numbers divided by x. We have 3, 6, and 9. We can't go past 3. Like we did in the GCF lesson. Think of it like money. Somebody has $3, somebody has $6, somebody has $9. Can you all go to a movie that cost $5? No, this first person can't. You want to go to something that everybody can go to. So we can't spend more than $3. So our GCF has to be 3 or less. So we can't go past 3. So between 1, 2, and 3, what's our highest number with no decimals? Right, 3. That whole line has no decimals. So that's our GCF. So we divide that out, which you can get from your calculator, 1, 2, negative 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Negative 9 divided by 3 is negative 3. That comes straight from your calculator, that whole line. Then we just snowflake. So A times C on top. So remember, A times C up here, B on the bottom, AX on the sides. So 1 times negative 3, B on the bottom, AX on the sides. And we just we plug in negative 3 divided by x, negative 3 divided by x plus x, and we look for the bottom number over on the right. So we want to find positive 2, which is right here, negative 1, positive 3. Okay, then we simplify. So we don't keep 1's in front of x, so that's just x minus 1. Same thing over here, don't keep 1's, so x and positive 3. Then we solve. So x minus 1 equals 0, and x plus 3 equals 0. How do we solve? We add 1, so x is 1. Over here, we subtract 3. So x is negative 3. So that's your solutions. Okay, B, a little bit easier. This one is already solved for us, already factored. All we have to do is set it equal to 0 and solve. When they're already factored for you, you don't have to FOIL them out or anything. You don't have to check for GCF. We've already done everything for you except solving it. So how do you get rid of minus 5? You add it. So that'll be x equals 5. How do you get rid of plus 3? Subtract, so negative 3. And this is 2 times x, so we divide. So divide 2, so negative 3 over 2. Those are also your x-intercepts. So over here, your x-intercept, we have positive 1 and negative 3. So 1, 0 and negative 3, 0. And then on this side, we have positive 5, 0 and negative 3 over 2, 0. Okay, and then use your calculator to find the rest, the y-intercept and the vertex. Well, this one's in standard form, so your y-intercept is actually already given. Where do you find your y-intercept in standard form? Right, the c value. So it's just 0, negative 9. So all we need to find is the vertex. So we just plug it in. And this one's going to be a minimum right down here below the graph. So we're going to do second trace min. It should work because it's right there. If it doesn't, we'll zoom out a little bit. So follow whatever the directions say on your screen. Perfect. So we have -1 and -12 if we round it off. So -1, -12. Okay, for B, let's plug that one in. So x minus 5 and 2x plus 3. I want a little bit lower below the screen, so I'm going to zoom out just a little bit. You just hit zoom 3, enter if you need to zoom out. So this one's a min again. So we're going to do second trace 5. Nope, sorry. Second trace 3. Follow whatever directions say on your screen. And round it off to the, actually these are pretty perfect. So yeah, round it off, 1.75 and -21.13. -21.13. Your y-intercept on this one, you can find that from your table. Where do you find the y-intercept on the table? At 0. So right here, 0, -15. Perfect. Okay, so that's review, so you remember how to do everything before we go into completing the square. So when we're completing the square, we're just really taking square roots of a lot of things. The basic kind are just going to be just a regular x squared equation. So you actually don't have to do, you could do factoring on these and do your little snowflake, check for GCF, all of that. But because there's only one x here in all of these, it's actually a little bit easier. When there's only one x, you can solve it like a normal equation. Like if I said 2x equals 14, how would you solve that? You would divide by 2. So pretend it's just a regular x. So this one only has x, so we just have x equals 169. How do we get rid of a squared? What's the opposite of squared? Square root. So we solve these by taking the square root of both sides. So x equals, what's the square root of 169? That's going to be 13. Now, the thing about square roots is square roots actually have two answers. The square root of 4 is not just 2. It's 2 and -2. The reason it has two answers is because 2 times 2 is 4, but also -2 times -2 is 4 as well. So both of those give you a 4. That's why there's two answers. So same thing here. Positive 13 times 13 is 169, but also a -13 times -13. So we have a shorthand for that. So we don't have to write the answer twice. We just put a positive over a negative. So when you type this in the computer, you're just going to type positive, -13. Well, x equals positive, -13. So anytime you take the square root, you're going to have a positive and a negative. Okay, what about this equation? Pretend that's just x minus 49 equals 0 for a second. How would you solve that? You would add the 49 over. Same thing here, even though there's an x squared. You're going to add your 49 over. So 0 plus 49 is 49. To get rid of that squared, that's always going to be your last step. you're going to square root it. And remember, square roots have two answers. The square root of 49 is not just 7. It's positive and negative 7. Your calculator is not going to give you that. That's something you have to remember. If we do the square root of 49, it's just going to say 7. It's not going to give you the negative. You have to remember there's two answers. Okay, for C, pretending that square is not there, how would you solve this? You would subtract your 15, then what? Divide the 3. Once you've got x by itself, how to get rid of that squared, the last step is always square root. So what's the square root of negative 5? So if you're not sure, we can put it in the calculator. Square root of negative 5. This one's going to say a non-real answer. You cannot square root a negative. Cannot square root a negative. A square root means you took a number and multiplied it by itself to get that negative 5. So for instance, 4. 2 times 2 is 4. Negative 2 times negative 2 is 4. You can't multiply a number by itself and get a positive 4. You can do 2 times negative 2, but those are not the same number. That's not a square root. It has to be by itself. And you can't multiply a number by itself and get a negative. That's why you can't square root a negative. So all we put on these are no solution. Okay, and D. If this squared was in here, how would you solve this? You would add your 14. So 121. Divide your 2. And then take care of that squared last by square rooting it. Now, we don't know the square root of 2. We do know the square root of 121, and we can actually split this up. So these are rare, but occasionally you can split them up. What's the square root of 121? Well, that's 11. We don't know the square root of 2, so we just leave that square root of 2. And of course, it's always going to be positive and negative. So you're going to have x equals positive and negative 11 over square root of 2. You can always split these up. These are what we call exact solutions. There is another answer, and it's called your approximate solution, and that's just going to be getting the decimal. So we would do it in the calculator. 11 divided by square root of 2. And we would round this off. So your positive and negative 7.78. This is the approximate solution. Because we have to round it, it's no longer an exact answer. So your exact answer, if it asks for that, you're going to leave the square root if you can't simplify it. If it asks for the approximate solution, that's when you give the decimal. So we're going to take this concept of square roots and solve our quadratic equations by completing the square. So, by the way, this last example, this is going to help you with 1 through 6. So this goes to numbers 1 through 6. So if you want to go try those real quick, you can. And then come back. So example 2, this is what you're going to use for 7 through 10. So, we do the same thing that we did in lesson 1. Some of these are already going to be in vertex form for you, so we want to solve it for x. So how we do that is we set them equal to 0, and we want to get everything away from x. We do not FOIL these out. You will never solve for x if you FOIL these out. So all you're going to do is you're going to get rid of your minus 16, do the opposite, plus 16. So 0 plus 16 is 16. And we cannot FOIL this out. All we do to get rid of the squared is take the square root. That'll cancel out your squared. What you do to one side, you have to do to the other side. So we square root the other side as well. The square root of 16 is a positive 4 and a negative 4. So we're going to have two equations, two solutions. That square root and the squared, those will cancel out and just leave you with x plus 1 on both equations. And then you just solve for x. So how do you get rid of x plus 1? We subtract 1. So 4 minus 1 is 3. Same thing over here. Subtract 1. Negative 4 minus 1 is negative 5. So x is 3, and x is negative 5. Can't write straight. So let's try one. Again, we are not going to FOIL. All you're going to do is you're going to set these equal to 0 and solve for x. So we move our 144 over. It's negative, so we're going to add it. So bring down your x minus 5 squared. 0 plus 144 is 144. Then we're not going to FOIL this. To get rid of this squared, we're going to square root it. So that'll cancel out your squared and leave you with x minus 5. The square root of 144 is a positive 12 and a negative 12. So you're going to write your x minus 5 with a positive 12 and equal to a negative 12. Then we solve. How do you get rid of minus 5? Plus 5. So x equals 17 over here, and add 5 over here, and x equals negative 7. I'll try one from your practice, just to make sure we're comfortable. So number 7. So for number 7, we're going to set it equal to 0, and we want to move our 1 over. How do we move our 1 over? We add it. So positive 1. Then we don't FOIL this. We get rid of the squared by square rooting it. So that'll cancel out your squared and leave you with x plus 6. And I'm writing it twice because the square root of 1 is a positive 1 and a negative 1. And then we solve. So plus 6, to solve that, we subtract. So x equals negative 5. Same thing over here, subtract. So x equals negative 7. So in your blanks, y'all have two blanks. You're going to do x equals negative 5 and x equals negative 7. How do you get your vertex, though? Your vertex comes from your equation. If you remember from lesson 1, you're going to take the opposite of the parenthesis, so a negative 6, and you're going to keep the outside number, so a negative 1. Opposite of your parenthesis, keep your outside number. So y'all can try 8, 9, and 10. Okay, I'm going to go back to example 3. So this is the last type of completing the square. This is if it's not already solved for you, if it's not in vertex form. Sometimes it's going to be in standard form. So we have to convert it to vertex form. We did this back in lesson 9.1 if you need to go look there. All you're going to do is complete the square. And if you remember in lesson 9.1, I called this getting rid of the bad C. This is not the C we need. So what we're going to do is set it equal to 0 and get that C out of the way. So a minus 1, how do we move that over? We add it, so it goes away. That's how we get positive 1. Then we put our blank in. So how do we get that good C? So find your good C. We do our B divided by 2 and squared. So negative 6 divided by 2 squared. That is 9. So that goes in the blank. Okay, then we just factor it. So you have your shortcut here. We do x minus that b over 2. Oops, 6 over 2. Squared. So 6 over 2 is that 3. That's where that came from. On this side, we just simplify. 1 plus 9 is 10. So now that we've got it in vertex form, we don't need to move the 10 back over. We've already got it on the other side. We just need to solve this. How do we get rid of the squared? We square root. So that'll cancel out your squared and leave you with x minus 3. And then what's the square root of 10? We have no idea. If you plug this in your calculator, square root of 10, you're going to get some random decimal. If we don't know the square root, we just leave it alone. So you're going to have a positive square root of 10 and a negative square root of 10. Do not change it. And then we just solve. So how do you get rid of a minus 3? We add 3. Now, when you have this little square root on it, your 3 is actually going to go in front. So you're going to put a 3 with a positive square root of 10 and your 3 with your negative square root of 10. So you're actually going to put your square root at the end. Put your 3 in front. These are your exact solutions. Remember we talked about this on the first page. Your exact solutions are the ones that you don't have to round. These are just your regular square roots. If you have to simplify and round it, those become your approximate solutions. And you get those just by plugging it into the calculator. So you would do 3 plus square root of 10 and 3 minus the square root of 10. And you would just round them off. So 6.16 and negative 0.16, which is what we got here. So if your square root does not simplify, you leave the square root alone for your exact solutions. Then you round it off for your approximate solutions. If your square root simplifies, that's what we did on the first page. Those are going to have very good answers, and you don't have to worry about that. They'll be very nice. So let's try this one. So this is not in vertex form, so we need to get it to vertex form. How we do that is to get rid of your bad C. So this is a minus 18, so I'm going to add it over. I'm going to leave my blank in there for my good C. Negative 2 plus 18 is 16. And I have to put a blank for my good C on that side as well. How do we find the good C? We do 4 divided by 2 squared. 4 divided by 2 is 2. Squared is 4. So that's what goes in your blanks. Okay, then we solve. So we factor this side by doing x plus your b over 2, and then square all that, and then simplify this side. 16 plus 4 is 20. Okay, 4 divided by 2 is 2. And remember, we do not FOIL this. How do we get rid of the squared? We square root it. So your square root and square will go away. I'm going to go over here. That'll leave you with x plus 2. What's the square root of 20? Well, if we plug that in, we're going to get a crazy decimal. When you get a crazy decimal, you leave it alone. It becomes a positive negative square root of 20. So we write it out twice. X plus 2 with the positive square root of 20, and x plus 2 with a negative square root of 20. And then we solve. How do you get rid of plus 2? You're going to subtract 2. And remember, this is going to go in front. So it's a negative 2 plus your square root of 20. And then over here, same thing, subtract your 2, but it goes in front. Negative 2 minus square root of 20. It always goes in front. So these are your exact solutions. How do you get your approximate solutions? We're going to plug that into the calculator. Negative 2 plus square root of 20. And round it off. We always round to 2 decimal places. So 2.47. And then the same thing over here. Negative 2 minus square root of 20. 2 decimal places, so negative 6.47. Those are your approximate solutions. So exact, leave your square root alone if you can't simplify it. Approximate, get the decimal. Okay, so your exact versus approximate solutions. Which subset of real numbers does square root of 10 fall in? So if you remember back, way back last semester, we gave you this box, your real number system, and we gave you rational and irrational, then we gave you integer, whole, and natural. Where would we find square root of 10? Well, square root of 10 is not a perfect square. If you plug it into your calculator, you're going to get a very long decimal. Your non-perfect square roots that are very ugly numbers, those always fall under irrational. Anytime you have an irrational square root that you can't find the square root of, it's some ugly decimal, these are always going to have exact and approximate solutions. So when you write a square root as a decimal, you have to round it. Once you round that number, it's only an estimate. That's why they're called approximate solutions, because it's literally just an estimate of that answer. It's not exact anymore. So that's why your non-perfect square roots are going to have exact and approximate solutions. And the last thing, when you have a negative square root, we talked about that a second ago, negative square roots are not real. On a graph, that just means it never crosses the x-axis. That's why you're getting no solution there, because it doesn't have an x-intercept. It doesn't have a solution. You're going to learn more about imaginary and how to work with those when you get to Algebra 2, but in this class, anytime you get a negative square root, you're just going to put no solution. Okay, I'm going to do a couple from your practice just to make sure we're good. And then I'll let y'all do the rest. So I'm going to go to the very last page. You can write these down and save them for later, for when you get to your practice. So I'm going to look at, I'm going to do number 12. So when you're doing these on the back, on the last page of your lesson, you're going to have a lot of blanks. You're going to have exact blanks, and you're going to have approximate blanks. If your square root is perfect and you get answers like x equals 2 and x equals 5, you're going to put that in both set of blanks. If you get like 2 plus square root of 5 and 2 minus square root of 5, those are going to be your exact, and then your approximate would be the decimals. So if they're good numbers, put it for both. If they're non-perfect numbers, the exact are your square roots, the approximate are your decimals. So I'm going to do 2 of them with you just to make sure you got it. So for number 12, yeah, I'll do number 12. We want to find our good C. So this one, our bad C is already on the other side of the equal sign. So we just need to put our blank in. How do we find our good C? We're going to do 6 divided by 2 squared. Your B divided by 2 squared, which is 9. Okay, then we factor it. So you're going to do x plus 6 divided by 2, which is 3. And then add this side, so 16 plus 9 is 25. Remember, we're not foiling this. How do we solve it? We take the square root, so that your square root and square will cancel. That'll leave you with x plus 3. And then the square root of 25, that's not just 5. That's plus and minus 5. So we split it up. And we solve. How do we get rid of plus 3? We subtract. So 5 minus 3 is 2. Negative 5 minus 3 is negative 8. These came out to very good numbers because your square root was perfect. So this is what you're going to put in for your exact and your approximate. So put it in for both of them. Okay, and I'll do number 16. So number 16, we need to get rid of the bad C. So we need to set this equal to 0 and move it over. How do we move that over? We subtract it because it's already positive. So negative 3. How do we find our good C? We're going to do our B divided by 2 squared. So 10 divided by 2 is 5. 5 squared is 25. That goes in your blanks. Then we factor. So x plus 10 divided by 2, which is 5. And then over here, negative 3 plus 25 is 22. How do we solve for x? We take the square root. So that'll cancel your squared. So x plus 5, square root of 22, you can plug that in. That's not going to give you a good answer. So we leave our square root alone. So we'll have a positive square root of 22 and a negative square root of 22. And then we solve. How do we get rid of plus 5? We subtract it. So negative 5 plus square root of 22. Same thing over here, subtract it. Negative 5 minus square root of 22. Remember, your negative 5 has to go in front. Which answers are these? These are your exact solutions. How do you get your approximate? You plug it in the calculator. Negative 5 plus square root of 22 and negative 5 minus square root of 22. Round it off to 2 decimal places, so negative 0.31 and negative 9.69. So x equals negative 0.31 and x equals negative 9.69. Those are your approximate solutions. Okay, so you all try the rest, and good luck.